All right. Hi, everyone. Thanks for coming. My name's Aaron Hall. Is it on? Any better now? Okay, it's this way. Awesome. Yeah, thanks for coming. My name's Aaron Hall. I'm a consultant at Source Allies for a little over a year now. I have a PhD in physics. I did my PhD at Lehigh University, focusing on computational biophysics, cell biology. And then I did a postdoc at Los Alamos doing some computational virology stuff. I say all that, and it may sound like that gives me the illusion of authority or something on this project. I just want to say this up front. This is just a personal project. This is not research that I'm publishing. It's not peer reviewed. I'm not an epidemiologist. I'm not a medical doctor. This is just something that I worked on because I thought it would be fun to work on. So just making sure that that's clear. So where did this come from? So I have a son. He's 2 years old. He's very happy. He's in daycare, which means that I often look a lot like this. I'm very sick all the time, my wife and I. And I just wanted to know, when am I going to get sick? So how can I know when I'm going to get sick? Well, we often hear from other people like, oh, some people are out sick, must be something going around, but that's about all we really hear. Like, how do we know is something actually going around, what's going around, that kind of thing. And if we have like allergies, you can check a weather app and it'll tell you what kind of pollen is common right now. And that can help you manage your allergies. But to my knowledge, when I thought about this, I'm like, well, we don't really have anything like that for illnesses. But actually, it turns out that we do, kind of. We do this thing called CDC wastewater surveillance. They collect data about what illnesses are going around, and you can go to their site, and there'll be a state level, like influenza A levels are low right now in Iowa. This is from a few days ago, so this is accurate to what's on the site probably right now. And you can see there's various little dots here with different levels on the different dots. And we have, wastewater monitoring all over the country at these different sites. I'll talk a little bit about what they're doing to get that data in a bit. But I wanted to kind of show how this site works and kind of motivates why I decided to make my site. So let's say we want to go to their site and we want to figure out what the levels are in Polk County for COVID, influenza, and RSV. So let's do that. I pre-recorded this just in case things messed up. So we go to their website, and I type slowly because I know I'm recording myself. This is all very user-friendly, as it looks. And so we're on the Influenza A tab. We have to select Iowa. That switches to Iowa. And then if we want to see Polk County, we have to mouse over where Polk County is. Sorry, the video is a little bad frame rate. Switch over to COVID. We got to select Iowa again. We got to scroll down again and mouse over Polk County to get what the value is there. And similarly, if we want to check RSV, we got to select RSV. We got to go all the way down there to Iowa and select that, and then mouse over Polk County to see that. So for my site, you go there after I type the URL. And when you first load, it figures out where you are and tells you what the levels are. And if you want Polk County, you put in a zip code that's in Polk County, and it tells you what the levels are. So that's a lot easier. That's kind of what I was aiming for. I did cheat a bit here. So now I'm putting in the zip code for Santa Fe, which is not cached. So that will take about 90 seconds to do. And I will spare you waiting 90 seconds watching this spin. But trust me, yeah, it takes that long to calculate. So yeah, it's not as lightning fast as that, but there you go. It can cache, and now that that's been calculated, that'll be cached the next time someone looks at Santa Fe, that'll be there. So that was the goal. And I built this SICRIS thing. So just generally how it works, and we'll talk a bit more about some of the other aspects of how it works, is I have a data ingestion pipeline that runs weekly. This is in Google Cloud. We pull the data from the CDC because they have it available. We keep historical data there, and we have some pre-calculation that happens on zip codes that we want to pre-calculate on. If this was a bigger thing, I could just pre-calculate every zip code, but I don't really want to do that, so I only pre-calculate a couple of zip codes, as you saw. We have a fast API like service to serve things up. So you hit it with that API risk with your zip code, it'll give you a response. And then we just have a simple React TypeScript front end to interact with that. And some pretty basic Python tooling with rough, Tye, PyTest, et cetera. So just to talk about how this wastewater surveillance works, in case you're interested. So it is literally wastewater. So this is like sewage, right? So sewage goes in the drain. It gets, to these wastewater treatment plants. It gets treated, and whatever else happens to it. But if you're sick, you're shedding DNA and RNA, and we can detect that in wastewater. And basically using PCR, like you might have had to do during, COVID pandemic and stuff, we can do that on wastewater. And that's cool because you don't have to go to the doctor, right? Like if you're sick, that just comes out of you. we can check it. We don't have to rely on people going to the doctor. We can just do that. And so the CDC tracks influenza A, COVID-19, RSV. Those are very common, so they're constantly circulating. Also, lesser common things like measles and mpox are tracked. I didn't bother with that. Like, if you want to know if measles or mpox are going around, just check the news. Like, that's so rare, it'd be hard to do anything with a tracker like this. And their data is freely available via API. You can just hit the API and get it. But there are limitations. Like if you saw from the map, there's limited coverage. Like the whole state isn't uniformly covered. And they do only weekly reporting, but there's also gaps. So they do a dump of data, I believe, on Friday or Saturday. And that's just whatever the most recent data is, and that gets thrown up there. But yeah, some sites will report every week. Some sites will report infrequently, et cetera. The other weakness for this purpose is it's primarily intended for public health officials and researchers and stuff like that. It's not really intended as like, here you go, public, this is what, it's not intended for what I'm trying to use it for, which is a weakness. But they do calculate these like things that we saw on the site where it says, the activity for influenza A is very low for like the state, and you can get that for the whole country as well, and that's what they call these wastewater viral activity levels. And that's what I saw when I went to their website. I'm like, that's cool, like that's available, that's awesome. So they use a historical baseline of the site, because each site might have different oddities with how it reports the data. They only use sites that have reported recently, and then they calculate per site, but they report the median for the state level and then other regional levels like the country. You can see just like what this would look like over like a period of a few months. This is some fancy statistical stuff that they do to calculate this that is beyond the scope of this talk. So I thought this was cool. So that was kind of my motivation, was they have this data, it's available, their UI leaves something to be desired. I can make a UI that accesses this data more easily, and that would be great. And that's something I can use a coding assistant to do, right? I hadn't tried anti-gravity, wanted to try anti-gravity. I hadn't used G-Cloud before, wanted to use G-Cloud. It's a great way to learn a few things very quickly. And if that was the end of the story, then I would have just started a coding assistant and had it do it and then be done, and then that's great. Unfortunately, that's not the end of the story. Or fortunately, I don't know. It depends on how you like to handle things. it did give me a lot more to solve. This is what you get in their API response for one site. There's a lot of stuff in there, and a lot of it is not particularly useful for what we're doing. But one thing that is missing is that W value, that risk value, is not in there. They do not make that available via API. They do have R code to calculate it that you could download and run if you wanted to. And what's funny about the R code is it says that they converted Python code to the R code, but only the R code is made publicly accessible. So apparently they have Python code somewhere, which I would much rather use than R because I don't like R. And so I thought, well, the W value isn't accessible, and I don't want to run R code, so I guess I'll just make a simplified version myself, which was my first mistake. Instead of using their documentation and just trying to copy what they did with my own code, I tried to do it myself. And it started out simple, and then I kept hitting different problems. And eventually, I kind of came up with something that's pretty much the same as what they're doing, but arbitrarily different in ways that don't make a lot of sense, but it's very similar. So one of the things that I really want to do is just kind of switch this over to what they're doing. So this is how we're calculating that risk score per wastewater site. So similarly, we do a historical baseline per site to figure out what's typical for that site for that virus. And then we can take thresholds. So if it's above 70% of what it normally is, we can say that's high. If it's above 50%, we can say that's medium. If it's below 50%, we can say that's low. And then we can exclude site data older than 14 days. And in testing, when I look at this seems to make a lot of sense. It seems to be pretty similar to what they're doing. But yeah, this was the kind of thing where I thought I would just come up with something simple and it would be fine. And then at the end of the day, I kind of built something I probably didn't need to, and I should just make it the way that they did it. But this is what I have at the moment. So that's one problem that's solved, let's say. The other problem is states are not homogeneous, right? This is New Jersey, and you can see for the whole state, they're saying COVID-19 levels are very low. Right now, in most of the country, most of these levels of COVID, influenza, and RSV are low, just because of the time of the year that it is. So I had to look pretty hard to find a state where the levels were a little higher. But yeah, New Jersey, there you can see that although the whole state is maybe on average low, over here in Newark, New Jersey, there's this quite very high dot, and that's not low. What if I live there, right? Like if I live here, and I say, oh, COVID levels are low, that's not really telling me that accurate of my circumstance, right? Like in my local area, they're pretty high. So what do? I mean, if I look at my thing, it says they're medium and rising, and we'll talk about how I was able to do that. Another thing is this is right next to the airport. It's a fairly high density area. That's why it's probably high as opposed to other places. You can see there's another high area here. But yeah, a lot of the other places are low. Whereas over here, this is Point Pleasant Beach, New Jersey, and this says it's low. So that's what I want, right? Like I want to be able to say what is the risk level where I am, not just for my whole state, because that matters to me. So I could just, go into that CDC site and I could look at this map and I could say, okay, I live here, and I can just make a general guess, but I'm trying to make a UI that just gives this to me for free, and I don't have to do that. I don't want to think about it. So yeah, people know their zip code. They don't know their wastewater site, and I don't know if you do. You might. I don't. The other thing is the CDC data and that response is by something called FIPS, which maybe people here know what that is. I had no idea what that is, so now we're going to learn about FIPS codes. FIPS codes basically correspond to your county. It's like a county code, and they have this part that's your state, and then they have a number for that. So each county has a FIPS code. So zip codes, they can exist within or across FIPS code boundaries. Wastewater sites can serve one or more FIPS codes. Multiple wastewater sites can serve the same FIPS code. It's all over the place. And this is what I was thinking when I got to this point in the project. So let's go through these different cases because we got to figure out how to handle them if we want to be able to serve this data. This is what we need to do. We have a zip code, right? We need to make a zip code into one or more FIPS codes. And then based on those FIPS codes, we grab our wastewater sites. And then we need a way to combine those per site risks into just a finalized score that we're going to hand back to people, right? That's our goal. So we have a simple case where we have a county, Apple County, has a FIPS code and has a wastewater site, has a zip code that's completely contained in there. That's easy. All we do is return this, whatever the score we calculated for this was. We just give it back to the user. We're done. Simple. But then there's this case, the ambiguous FIPS case. So the zip crosses over boundaries. Each county has its own wastewater site. How do we handle that? We outsource it to US zip code, which is a Python package, because I didn't want to figure this out. Basically, US zip code is a Python package. You look up your zip code. It just assigns a county to that zip code. So there's a lot of different ways that you could think to do that. I tried to investigate a little bit what they're doing under the hood. I'm not exactly sure. They might have different cases for different cases. You could think, okay, well, look at what this shape of my zip code is and what it most overlaps, and we could assign it that way. There's a lot of things that you could do. I didn't want to do that, and this Python package is already doing it. So I've just taken them at their word that that's a good idea, and then we'll move on with our day. So let's say it assigns it to Apple County, then we just take the risk for that, and then we leave. We're done. There's another place where we have an ambiguous site case, where we have a zip code that's contained in this county, but this county has 2 wastewater sites. Now what do? We can't, I mean, we could assign it to this one, we could assign it to this one. Well, we could use all of them, and then we could just distance weight them, right? We're closer to this one, so this probably should contribute more to that score that we give. This one could contribute a little bit less. That makes sense, we can do that. And then there's the no site case. Not every county is being served by a wastewater site that's reporting anyways. So Apple County here doesn't have a wastewater site, these other ones do. So what we could do is we could use all sites in the state, and then again, distance weight them, and then return. That's what I came up with. Those are choices, and they're underlying this model, and I think they're reasonable choices. I have not verified them in an explicit way. That's what I was saying about this not being peer reviewed. But those are the choices I decided to go with. So when I was showing you these 2 cases, these are actually different aspects of that case. In Newark, New Jersey, this one is an ambiguous site case. There's 2 sites that serve this county. You can kind of see them. There's this one that's light blue. There's this one that's dark purple. And then this ended up with a medium rating after it did the weighting. And then this one is a no site case. There's nothing in this county. So it's just taking all of them and distance weighting them and coming up with a low. So I can kind of show how this looks because I've just been showing the front end. So this is the anti-gravity IDE, which looks very similar to VS Code if you've ever used VS Code. Like I said, I wanted to use this project because I wanted to try out the anti-gravity IDE. Unfortunately, anti-gravity IDE is kind of being phased out, but that's what I used, so use it for that. So I can run locally. I can run my service using Uvicorn, and then that'll sit there and then wait for somebody to say something. And then another terminal, I can curl that with a zip code. Yeah, the font is very low, sorry, but this is just 50010, which is one of the zip codes in Ames. And maybe it'll work. Maybe it won't. It's calculating things. It's not getting a cached response, so that's probably going to take a bit. But you can see above what a response would look like. That's really hard to see. So we can look over at, this is the cache. I keep a JSON cache of the various responses. So we can find, this is Ames. I want to find Newark. So you can see Newark, New Jersey in this response. I mean, you can read that maybe. I'm sorry the font is a bit small. And we can see there's different sites, and they have weights assigned to them based on these distance measures. And then these are the scores that were assigned for the viruses, their various levels. And we have all the site details. So this is what this site got for those viruses and the weight. This is what this site got and those viruses. And when we look at Point Pleasant Beach, New Jersey, it's a bunch of sites. And then, so this response is enormous. It's got a ton of information in it. So I could probably do some whittling down of what I'm sending back. But this is what I'm sending back at the moment. And it's nice for me because it's good to debug. But it's definitely way more than the front end needs. But that's what there is right now. All right. Well, I forgot to go back to slideshow, so you saw everything. So yeah, are we at the beginning or the end? So this data is not that frequent. It's only updated once a week. And what actually gets put up there lags behind the time that it was updated. So it updates, like I said, at the end of the week, so Friday or Saturday. But the data that gets uploaded could be like a few days old at that point. And then it won't get updated for another week. So things could be a week to a week and a half old. Sites could have skipped, so it could be even older than that. That's why we have to put like a limit on what data we'll consider. So we kind of want to know, like, sure, this is medium based on that data, but what's happening? Like, is it getting worse? Is it getting better? Like, if it's medium but it's getting better, then probably by the time I'm looking at it, it might not be that big of a problem. I have a pretty simple way of doing that, and maybe there's a better way. But what we do is we look at the trend of what the score has been for the last 4 weeks. We just do a simple linear regression. That's what I'm overlaying here. And if the slope of that linear regression is large enough, then it's rising. If it's negative enough, then it's falling. If it's flat enough, then we just leave it. It's stable. I'm sure there's a lot of times where that's going to fail, and it's not the greatest way to do it. But it's a pretty good first approximation way to do it. So yeah, I mean, I've highlighted some of this going through, the weaknesses and limitations. So like I said, upfront, modeling choices, they're not supported with comparisons to real data. It's not peer reviewed, et cetera. It arbitrarily differs from the CDC's W-val score. I really want to correct that. I hadn't really noticed this until preparing this presentation. Like, these are choices I had made going along, and you get kind of tunnel vision in a project, and you're like, yeah, this all makes sense. And then you take stock, and you're like, wait a minute. I'm practically doing the same thing as them, but it's just different a little bit for no real reason. So that's one of the my big takeaways from this is that I should probably just be doing the way that they do it. There's distance approximations. There's that US zip code, zip mapping to the county thing. That's definitely an approximation. The distance calculations themselves are using centroids of things, so that's already an approximation. And yeah, just the data quality. Sites report erratically and things like that. So when I first was thinking about presenting this, I was thinking, oh yeah, I used AI development with this, and I should probably talk about that. And I feel like I started this project a few months ago, and I feel like already it's out of date. And I don't know if I have that much to say that's that relevant to how coding assistants are being used now. But yeah, I used anti-gravity. I did not want to pay for it, so I was using the free tier. I guess one of the big things to take away is anti-gravity is one of the only free ways you can get access to some pretty good models, like Opus 4.6 and Sonnet 4.6. You can get some tokens for those without paying anything. But you will run out of tokens in like an hour to 2 hours of doing anything. They just run out nearly immediately. But yeah, it refreshes weekly. So yeah, my workflow is primarily human in the loop. I would have it do a plan. I would implement in small chunks, review before committing, try to do TDD as much as I could, or just have testing in general, but there's some lack of rigor there. And like I said, at the beginning of this, I thought this was really going to be a different front end for data that was being served in an API. I just hit go, let it go. That definitely wasn't the case, as you can see from this presentation. There was so many different choices that I had to make, and none of that, sure, Coding Assistant helped with brainstorming a little bit, but it's the things it might have come up with, how do you map the zip code to they're terrible. They're absolutely terrible. So yeah.
Sorry to derail.
No, it's fine.
I don't want to take away from what you did because I think it's really cool. But we said before, you ingest the data gets published weekly, and you're ingesting it per query, right?
No. So the data gets, they upload all their data at once. And then, sorry, I talked about this way in the beginning, and then, so I have a cron job that happens immediately after they upload their data. It ingests all of their data, and I can pre-calculate some of the scores if I want to, but when people hit the zip code API, if there's a cache score, it just grabs the cache score. If there's not, it uses the data that's stored in the bucket on Google Cloud to calculate the risk. The risk is what gets calculated when you hit the back end.
Okay, so
I'm pulling the data.
Is calculating the data when it gets published. And
yes.
The actual risk score is either been.
It's either been cached or it's calculated on demand. Yeah.
I'm just curious. I don't know.
No, it's fine.
You can add later on, but why not do a heat map so that
yeah.
you get data, calculate it, and then you just generate a map so that it's visible for the user. If that makes sense.
Yeah, like a heat map for the whole U.S.
You did it insane. I couldn't do it. But it's
No, that's definitely something I thought of, and like I said, if I was going to go to the next level or fund it or whatever, I would calculate this for every zip code just right away. I would not 90 seconds is too slow. I mean, that's just way too slow. I mean, I could probably optimize that, make it a little faster or whatever, but however faster I make it, it's still probably going to be too slow. Yeah, so it'd be much better to just cache that. And the data is only refreshing once a week, so I might as well just do it right away. Then I'm just hitting that and just pulling it immediately, and that'd be great. And then if you have that for the whole country, you can make a heat map. You can do kind of whatever you want to visualize that. I could make a bunch of cool things on the front end to visualize that data. No, that's a great question. Anyways, so far as the AI stuff, it was really good for boilerplate stuff and brainstorming. I think that my Terraform is probably garbage on this project, but it doesn't matter that much because it's kind of a small project. If it was a bigger project, I would be worried about some of that stuff, and I'd spend a lot more time on it and make it better. But yeah, when I hit these kind of modeling problems or these more complicated, just how is this supposed to work kind of problems, that's where it tended to fall apart. You have to kind of have a huge amount of knowledge into the problem that you're trying to solve to be able to handle that. And that type of stuff, at least for me, it came I would hit a roadblock, I'd look at what the problem was, and I'd try to figure it out. And then once I knew, oh, this is the problem, then coding it is pretty trivial, so it doesn't really matter if I code it or the coding assistant, it doesn't matter. And then, I just want to say this just because I thought this was great, and I'm really sad to see it go. And if you know a thing that does a similar thing like this, one of the things I really liked about the anti-gravity IDE, you do a plan mode, it had it built in, and that plan comes up in the UI, in like a normal file would be in VS Code, and you can click on parts of the plan and just comment in line. You can comment all over it in line, and then you can send it back and say, hey, I made some comments. Can you revise the plan before we implement it? And I really liked that. I really liked being able to inline edit the plan. I know they all have plan modes, and you can provide feedback, but this was a really nice way to give feedback that was just built in out of the box in the IDE. But as of Anti-Gravity 2, they're not really supporting the IDE, so this is probably going to go away. This is just me yelling that, I thought this was cool. If you know something that's like this, that is going to be supported, let me know, because I think it's really cool. But yeah, that's what I got. I hope it's interesting. If you got any questions, yeah, let me know. Sure. Sure.
So we got the positive signal, which is like, hey, there's viral proteins.
Yeah.
It's kind of like your numerator on the risk score. Do you model like the denominator of like total flow volume through the water system? Like, does that matter? Like, rain happen and all this.
Yeah, like the more water comes in like that. Yeah, so I think they take that into account into the API. I think there's one where it's just like raw, and then there's a way that they handle it that's based on water flow. I believe so. The other thing that I do is just, comparing the historical baseline. But yeah, I do believe that they have two ways of reporting concentration, and one takes that into account. Yeah, it's definitely something I should be able to give you a more concrete response. But I do know that that's important for these values. Like, if a bunch of water comes in, yeah, like that definitely changes those concentrations. So I do believe that gets, it's considered in some way. There's a value that they report that takes that into account. How it takes into account, I don't remember, but I do believe that is the case. It's a good question. I would have had no idea to ask that question until I did this project. Do you have a question?
How often do sites sample their water?
So the ones that sample the most are I think weekly. Yeah, but yeah, not everyone samples weekly. I think there's some that don't sample at all, which is unfortunate. But yeah, and then some will just randomly not sample sometimes. Yeah, so if there could be more frequent sampling, it could help, like something like this. Not necessarily me, but like if like the CDC wanted to enable something like this, like yeah, sampling more frequently would really help that. And then just having more sites sample. Yeah, I mean, I think right now it's just if they want to sample, they sample. I don't know what the motive, like how they get people to sample or whether they decide to or not. Yeah. It seems like they just can if they want. I don't know. I didn't look into that. Yeah.
So how inconsistent is how you manage your cache? Do you just validate the cache every week, or do you validate the cache when you sample that site?
Well, the cache is just for the week. The historical, the historical data, I just keep. So I take everything that I got and then I append to it as I run the cron job. So if there's a gap, like let's say, like for Ames, right? Like let's say Ames has been reporting every week, and so that's great. So I can just pull from that one place and then I get the value. But let's say they just suddenly stop reporting. I built into mine, like if it's older than 14 days, then I just don't consider it anymore. Like it gets considered for the baselines when you calculate the historical baseline, but it's not considered for calculating the current risk level. That's calculating with the most recent data that it can get. And if it's older than 14 days, it's just, no, I'm not going to use that. So if you're in Ames and they stopped reporting and it's been more than that 14 days, it would fall back to the distance weighted of the most fresh stuff from the whole state. Sure. You and then Matt. Well, you first. Sorry, I don't know. I know his name. I don't know your name. Sorry.
I know you had the formula before. I think it was when your value is on top. It's kind of piggybacking on what you said. It's over the standard deviation.
Sure. So yeah, you're talking about the W value.
W value score.
Yeah. And mine does something similar, but yeah. So it has. This is what the historical baseline is. This is the standard deviation. Yeah. Oh, okay.
Like the population density is significantly higher. So, like, does either the CDC or your formula factor in, like, saying that? Like, I'm trying to put this to words. Like, you have a higher presence of pieces like toxins in the I know you're still kind of like factoring in standard deviation and historical data set, but are you still factoring in like the population, like just the larger volume?
Yeah.
Of
Like, so there's just more people, so there's more volume. I don't know if that would affect the density. Like, this is a concentration, so it's over like the density of the water. I don't know if how many people are in that area. I don't think that would affect necessarily the density of viruses in the water.
Because it's capped by the total volume of water.
Yeah. Yeah, and somewhere in here, so there's a lot of different ways that they say the concentration. There's flow pop and this average concentration linear. I believe one of these considers what you were asking about before. I don't remember which one, and I'm sorry, I don't remember the details, but I do know that's something they do consider.
I'm not trying to ask you a gotcha question.
No, I know.
I'm curious.
No, it's a good question. Matt.
I have a couple questions.
Sure.
My first question is, so you kind of look back over the 14-day
Window, sure, yeah.
right? So initially, did you have to like pull in historical or like kind of backload stuff when you didn't already have something running to do like an initial load to get that?
Oh, yeah, just like grab all the history, yeah. So the API allows you to give like the range of data that you want.
Okay.
So yeah, initially I just did like a year, or I think I just did everything. I just pulled in everything. And then when I do the weekly job, I don't have to pull that much data. I can just pull what I need since the last time. And you can just specify the range that you want. That's the CDC's data API. They allow you to specify the range of data that you want to pull in. So
Okay,
yeah.
that makes sense. My other question, kind of similar, but I think you might have just answered it.
Sure.
was When you have a scheduled cron job to like pull data.
Yeah,
right?
yeah.
And you're pulling for a week at a time.
Yeah, I believe so.
And so then is that just one single API that just dumps everything, or do you have to do it like by state or by site, or
Oh, it's everything.
it's just one API that returns?
Yeah, you can just get everything. I mean, you might be able to parameterize it if you just want one state. I don't remember. I wanted everything, so I just grab everything.
So how big is that because it's for the entire country, right?
Yeah.
Is that just the 50 states, or is that like also other like territories?
It's just the 50 states. So we have this historical record. I don't know if I can see the file size here. I mean, you can see I'm on like line 2 million or something like that. I think this is at least a year of data. I think it's like 50 megabytes. I don't remember.
Okay.
It's pretty big, yeah. And you can see I'm not, so, yeah, this is the example response. I am not storing that much information in my history because I don't need all that information. So I at least, whittle it down for what I'm storing in the history. But yeah, even with a smaller thing that I'm storing here, it's still just a ton of data. Yeah. Sure.
Does the CDC have any infectious disease reporting that you can back check it against to say this is the viral concentration versus the at least proposed concentration of the population that's been diagnosed with COVID?
I'm sure that exists. Yeah, I mean, yeah, there's probably a data set out there. Like if I go back to my grad school days and I'm like, okay, well, how do I verify? That's the first thing I would be like, okay, what are like the hospitalizations or whatever for COVID? Like that's at least some signal to tell you that this is like telling you something, right? How good that data is, I don't know, but I'm sure that kind of data exists, and that's the kind of thing you would need to like verify this. Yeah, the one thing I have is like, if I'm just using W-vals, like that's something that is published. CDC has published that, say how to do it. The other thing that I would be doing is the mapping from zip to those vals and like weighting them in some way. That's a different choice. So figuring out how, like, is there data that is fine-grained enough to motivate or verify that choice. Like, can I tell that, like, bringing up New Jersey again, like in that part of New Jersey where there, this meant there was more hospitalizations per capita compared to this other rural part of New Jersey. Can I find that kind of data? Be like, yes, it worked. And like, that would kind of just tell you, I think regardless of what the data looks like, it would kind of just tell you what you kind of already know, which is, yeah, there's probably more illness where there's a lot of people, but like, is my specific way of weighting good versus some other random way of weighting? I don't know if the data would be detailed enough to do that. Yeah, there's not always the ideal data set to verify the choice that you want to make, but you should at least try, ideally. Yeah. I think someone else had a hand up, maybe? Yeah.
Just going back to the FIB.
Sure.
Something for the zip code, or like A and B, and you choose one?
Sure. I could bring those up.
I think you said they kind of just pick it and that's it. I'm just curious if there's like.
Do you mean this one, this ambiguous case? Yeah.
So I'm curious if there's another way to do it, and then like do like a sample for a different centroids.
Yeah, there's a lot of ways that you could solve this. So like maybe, like, yeah, you could take the centroid of this county, the centroid of this county, and then the centroid of the zip maybe, and like compare. That's maybe a simple way to do it. I think there's also data, like there's a lot of this, like for this kind of stuff, there's just a ton of data. Like I think you can actually get like the outline of these things and like overlay them and see how much they overlay with each other. And like you could do that if you want to. I think that's possible. And like I said, I'm not exactly sure what they're doing in this package underlying. They might be doing some of those things or all of those things in different cases. Yeah.
Is there a published data set for like what zip codes are associated to wastewater? Because I don't think it's a nationalized system like the wastewater facilities, like what zip codes they serve.
They don't serve zip codes. They serve. They do, yeah. They like that is like how they're basically defined. So like if you go into here, when we're looking at this cache data.
So each wastewater is associated to a FIPS code.
One or more. So like this ID, this is the ID of a wastewater site, and you can see it's just two numbers, and that's actually the FIPS codes that it serves. But it's not a unique, like it's not unique in any way. Like one wastewater site can serve multiple FIPS codes. Two wastewater sites can serve the same FIPS code. There can be all different combinations like that. But their ID is always like what FIPS codes they serve. So that they are associated with the FIPS code that they serve.
So your transformation is just figuring out which zip code falls under the FIPS code.
Basically, yeah. And then how to handle. So then you get matching sites, but then it's like, okay, how do I handle those sites? Like there could be 2 or 3. Like how do I average? How do I aggregate that data? Yeah, sure.
That was another interesting potential use case. You back to that New Jersey example.
Sure.
Play it forward and maybe see if you see any changes to the risk score for adjacencies.
Well, like, is it growing?
Infectious risk here, right?
Yeah.
Areas, therefore, the switches.
That's cool. Yeah, that's a cool idea. Yeah, if this has a high risk, then to the nearby is it growing in some way? Yeah, these become complicated epidemiology questions that are, I'm sure, very difficult to investigate. But yeah, it's very interesting. Sure.
If you had enough, let's say you could get 2 years fully funded to do whatever you wanted with this next, where would you take it?
I mean, we talked about some of the things that I would want. The researcher in me just really wants to verify, like if you're publishing something, like any choice that you make needs to be like motivated in some way. Like you don't want, as few arbitrary decisions as possible, and there's a lot of arbitrary decisions here. So yeah, swapping over to W-vals, that takes out choices, right? I didn't make any choices. This is published stuff that someone else did. I don't have to think about that. But then that becomes, like, the heart of this is that mapping of the zip code to the FIPS code. That all needs to be motivated in some way. So finding data to motivate it as best as I can. Like, data is imperfect. You got to use what you got. But yeah, doing that. That's the research part that I would really want to make sure is good. If there would be any way to collaborate, yeah, to like increase sampling. I mean, if we're talking lots of money and lots of time, sure, yeah. Get them to sample more to support something like this, that would be great. But then just like, I think a lot of the things you were saying are like the kind of things I was thinking of. Like if I was going to continue with this, different ways to visualize the data is kind of what I would want. Like being able to like have interactive graphs like this, being able to have like heat maps, like any like fun way that you want to look at this data so you can kind of see what's happening. Like that would be the kind of stuff that I would want. Like this is a great graph, but I would love it if I could like, you know, change the range, if I could change to, if I could go to a particular zip code. This I think is for an entire state. It's not for just like one site or one region or anything like that. So like getting into like the data visualization part of it. Because that to me has been kind of the funnest part when I was doing research, is because you look at data in different ways and you really start to get different insights into what's happening. And so just having more options to visualize this data I think would be great. That would probably serve researchers like more, but that's kind of I guess how I'm approaching it from there. But yeah, from like, you know, normal people accessing it, like what's happening just out of curiosity, is like a COVID going around, that kind of stuff. Yeah, the heat map, that kind of thing is really cool. If there's anything else, I don't know what else. Do you have any other ideas?
I was just wondering if you were going to say, like, you would lobby Congress for regulation,
Oh.
requiring more sampling or more
I
reporting of data.
I would say that's not really how my brain works. I'm more like this project is really like a project that asks the question, what is a hobby and what is like work? and I've come to the conclusion that a hobby is like when I can say like, oh, I don't want to work on that right now. That's really kind of the only difference, because I just love like working on complicated problems, and that's really how I approach this. Because it really, legitimately, when I started this project, it was like, it really was because I was getting sick all the time. and I was just like, is something going around or not? Or are we just getting sick because my son's going to the daycare all the time? And that's probably more the answer. But I mean, we're certainly not getting sick that much now, and nothing's really going around. So like, they do correlate with each other. So that, it started with that. But then, like, if I think, I have allergies and I don't really check a pollen tracker. I don't know if anybody here does. So I don't know if I would use this personally, but just it got to the point where just like solving the problems to get the thing to exist was just fun to me. So that's kind of why I continued with it, as opposed to like me being like, no, we need to have this type of thing. That's not really how I approached it. Yeah. Sure. Yeah. There is. Yeah. I mean, I can write it. It's sickris.tetrastation.com. If you can guess how that's spelled, or I can just write it here. As I said, like it's as validated as I've explained. So that's I'm kind of in a place where I'm not sure how much I want to share it beyond, you know, things like this, because I think it's relatively accurate. It seems to agree with what the CDC has on their site, and I think the choices I've made sort of make sense to me. So it seems good in that way, but I haven't taken those extra steps that I mentioned that would make me a lot more comfortable to like shout to the world, hey, use this thing, you know, like, so that's kind of where I am with it. Yeah.
Is there another project that you have in mind that you would like to tackle?
Next project, I mean, the boring answer is like I always have like a video game that I'm working on, and I have one that I've like not gotten to work on that much recently, and I'm pretty far along with it. I'd love to get back to that. Yeah, that's probably the boring answer, because I think everybody has a video game that they probably want to work on. The people that code anyways. Coding and wanting to make video games seem to big overlap. But like a project like this, at the moment, no. I'm sure something will come up. Like I always just have random ideas. Is there anything that you're thinking?
No, I really like the presentation, the topic around elephants is, I think it really brings great conversations about projects that the community put together for this time.
Yeah. The thing I like about projects like this is, yeah, I learned a lot of random things. Like I did not expect that I was going to have to learn going into this project. So, I mean, if I run into somebody on the street, I can say, hey, do you want to know about wastewater sites? I can talk to you about it for like an hour, you know? And it's more interesting than you might expect. And some of this I knew a little bit because of like the type of research I had done is not directly related, but tangentially related. And then, yeah, the other stuff is just you dig into anything and you're like, okay, now I got to know this to figure out this next step. Now I got to, like FIPS codes, I had no idea what a FIPS code was. I'm sure they're very important to somebody. Yeah, but I had no idea what they were. Yeah.
More of a comment, I guess, but can you get like the GPS or something for the wastewater sites? Because for me personally, I've lived in a lot of like border areas. You know, one's not really one pretty in the middle of the state, but you know, it just seems like for a lot of places like this, what's going on in the state may not be especially relevant to me.
Yeah.
Like 50-mile radius or 100-mile radius, something like that. Just wasn't sure if that was available or even considered. Yeah, because all this FIP stuff seems a little bit unnecessary.
So, oh, you're saying like instead of doing the mapping.
Some sort of like 50 or 100-mile radius, something.
Oh, okay, yeah, just yes, skip that. Just go. Okay, this is the centroid of the zip code. Just what are the closest ones?
25, whatever.
Yeah, just take the radius. That's a simpler way to handle that problem. I mean, you could just distance weight always.
Yeah.
Like, I mean, you don't even need to, like, that's another choice, right? Like, you don't even need to consider states. I mean, I'm considering states, but there's no reason to. So you could just say, I live here. I'm going to just distance weight everything. If they're outside of a certain radius, probably the value is going to be so near zero, I'm going to ignore. So outside of 100 miles, maybe we'll just ignore, and then we'll just take that. That also has, like, I mean, some places might not have one within whatever radius you choose. So you have to consider what to do in those cases. Yeah. It could just be take the closest 20 and distance weight them, you know, like there's different choices you can make for that kind of thing. But that's definitely a different way to approach it. Yeah, might make more sense to do it that way, but like I was saying, like getting the data to like decide, is this way better, is this way better, it's hard, yeah. Because you do have other complexities with that, right? Like different states might have different just infrastructure and things like that. That could change and could make crossing a state boundary not necessarily what you want to do with this kind of data. I don't know. You could imagine there could be problems with that. So whenever you're modeling something, you have to make choices. And
And I can just think of so many exceptions, like upstate New York is very different than New York City versus.
yeah.
Just like,
Yeah,
I
definitely.
don't really care, you know what I mean? If you're living well north of Albany, it's like, yeah.
I think the distance, like if you're talking about like New York State and you live like far west in New York State, and you grab the closest, like probably this will do all right in that case. Like what you're talking about may be a more like a better way of handling it for those kind of cases. But this is still, it's either grabbing what directly serves that county, or it's doing a fallback to using distance weighting. And like, it's still gonna like weight the things that are closer, like heavily. So I think a bunch of people had hands up, so I don't know where to go. We'll go to you.
Just had another comment on another way to weight it would be DOT has annual travel rates for each road system. So as far as the radius goes, you could track a correlation between infection rate and concentration in a given area versus how many people are likely to be traveling through that area. And a good example would be Ames to Des Moines. How many people do we have going vice versa, either way to go to their place of work or daycare, and then also use that as another fork to model off of how fast do these concentrations spread in relation to high traffic
Yeah.
road systems.
Yeah.
That's free data.
That's definitely free data. I imagine that's what epidemiologists like use this data for. It's a great idea. I mean, I would hope they're doing that. I don't know.
Has this been going on for a while, or was this like new with COVID?
The wastewater sampling,
That's when I first heard of it, but I really wasn't sure.
I think that's when I don't know if it was going on before.
Yeah. 'Cause it
Not
seems
sure.
a little bit, immature, whatever you want to call it. It seems like it could be a lot more robust. You know what I mean?
Yeah, it feels like it's not as robust as it could be.
It's possible, yeah.
I think wastewater plants always sample their stuff.
But like, when did they start?
Yeah. So whether they share that.
We probably didn't get this robust until COVID, or
Yeah.
not COVID, because I think in high school, it's like a garbage and waste facility, and they talked about like sampling.
Okay.
slaughterhouses, and that was 2017.
Okay, so I guess they've been doing it for a while.
Yeah, it's fine.
Even since COVID is 6 years ago, like time is marching on. Yeah.
And is this the hosting site at Tetra Station, or
What?
is that like a hosting?
Yeah, that's my website.
Okay.
Yeah, there's nothing on the main page. This is the only thing on there. So I may put other things on this domain at some point, but right now this is the only thing that's on there.
All right, well, thank you very much.
Yeah. Thank you.